Hi, this is Jason Molesky. In this example, we'll perform some normal calculations involving p-hat. Suppose a polling organization asked a simple random sample of 1,500 first-year college students how far away their home was. Also suppose that 35% of all first-year students attend college within 50 miles of their home. Our problem is to find the probability that the random sample of 1,500 students will give a result within 2 percentage points of that true value. To do this, we'll perform 3 steps. First, we'll state our distribution and the values of interest. Then we'll perform our calculations, showing our work, and then we'll answer our question. So for step 1, we want to find the probability that p-hat falls between 33 and 37%. In symbols, that's the probability of 0.33 less than or equal to p-hat less than or equal to 0.37. We were told we have a simple random sample of n equals 1,500 drawn from a population in which the true proportion is 35% who attend college within 50 miles of their home. Well, what do we know about the sampling distribution of p-hat? Well, first of all, we know that its mean will be 0.35, and in order to use the standard deviation formula, we'll need to just check that the population contains at least 10 times our sample size. Since there are over 1.7 million first-year college students, we can feel fairly certain that that condition is met, and we can say that the standard deviation of p-hat can be found using the square root of p times 1 minus p over n. Calculating that out, we see the standard deviation of this sampling distribution will be 0.0123. Now, can we use a normal distribution to approximate the sampling distribution of p-hat? In order to do so, we'll need to check our large counts condition. Specifically, we'll need to see whether or not n times p and n times 1 minus p are both greater than 10. Well, calculating these, we see n times p is 525, n times 1 minus p is 975. Both are much larger than 10, so the normal approximation will be accurate. Therefore, our sampling distribution can be sketched as a normal distribution centered at 0.35 with a standard deviation of 0.123. We're interested in the proportion of samples that would fall between p-hat equals 0.33 and p-hat equals 0.37, so we can shade our area of interest. To find that proportion, we'll need to standardize the values at p-hat equals 0.33 and p-hat equals 0.37. We get a z-score of negative 1.63 for our lower boundary and a z-score of 1.63 for our upper boundary. Using table A, our desired probability in between is the difference of the values that fall below each of those boundaries. So 0.9484 minus 0.0516 gives us a total of 0.8968. Or in other words, about 90% of all simple random samples of size 1,500 will give a result within 2 percentage points of the truth about the population. For some additional practice in performing normal calculations involving p-hat, try exercise 39.